Hi everyone, today I'm going to teach you and help you how to use the level probe in the well for protection against the dry running, because in many cases the pumps will have problem if there is no water in the well, so it will burn the motor pumps. This is very important for VFD, the solar pump inverter, to protect against the pumps. Okay, we have three solutions to help you. The first solution is very economical. Customers only need to set parameters for the solar pump inverter as per the motor rated current. Now we need to understand and know the motor rated current, and also we need to know the motor, the empty node current. We call it the dry run current. As you can see now, we are doing the simulation testing. This very small motor is about 1.4 to 1.5 ampere. We need to set the percentage for the empty node current compared with the motor rated current. So this parameter 24.13 is very important. Default is 0. So we need to set this percentage. We can set 100% because this is just an empty motor. Okay, we press ENT. And we just do the simulation test. We can set one time, maybe 5 seconds. We can run the drive. So it will check the current is below the setting value. So the VFD, the solar pump inverter, will trip with one error. Discipline on the, you see the current now is 1.3. now it's tripped, error DRY, dry. So the VFD stopped and the motor has been protected. Thank you very much. Okay, the third solution, we can use a float switch. We can call it a level detection switch, digital switch, 2-wire digital signal. Okay, now the VFD is running now. Once the water level reached the sensor, the switch, the VFD, the solar pump inverter will stop. For example, stop. After 10 seconds, it will trip, LOL. It will show LOL. So it is tripped. You see? Motor stopped. VFD stopped. I hope you can understand. Number 3, third solution, we can use the analog float switch. In some case, customers, the float switch is the analog switch, 3 wires. So they need to connect terminal 10 voltage GND AI2 or AI1. For example, here we are doing the lab test 10 voltage GND AI2. Okay, we are do simulation, use a potentiometer. So we need to set the signal channel 4100. The default is 010. So we need to set 023. Okay, and we set the wake up level 50% and we set sleeping percentage 50%. So if the water level come to the middle point, higher it will sleep, lower it will running. Now we set the detection time 5 seconds. 41.05, 41.06, both are 5 seconds. Now we can do test. Do running. The inverter is running, the motor is running, okay? For example, the water level is coming to the 60%. So VFD will sleep and stop after 5 seconds. Oh, you see why? Because the wire is disconnected. We need to, so it stopped. Now the water level is higher. We turn back, it will run again after 5 seconds. As you see, VFD is running now. Just now it happened because the connection is disconnected. So we must ensure every wire is screwed, is tightly screwed, is well connected to make sure there is no problem for connection. Now the water level is lower down. The VFD will be sleeping and stop. Thank you. It's another solution for waterfall protection. It's very easy. Customers, engineers, workers only to short the DI3 and COM. If their float is a digital signal, their float switch is digital signal, 2-wire, short DI3 and COM. No need any parameters. Just short the terminal, start a drive. For example, now the water is arriving to the top of the tank. It have attached the sensor. For example, now the sensor is closed. After 10 seconds, the VFD, the solar pump inverter, will be alarmed. So it tripped FULL full. Now we can turn off the switch. It will be normal after 10 seconds. Because the detection time is 10 seconds, you can change the detection time by parameters in the user manual. Now you see it's normal, it's running without any alarming because the water have not reached the sensor. Now we try again. After 10 seconds, it will be alarmed. It will be tripped. Thank you.